Hello class, and for this week's discussion video, I chose to do the Crayon Rock Experiment. This experiment was a lot of fun. It was simple. I was able to do it pretty quickly at home, and I got to learn a little bit about the rock cycle through this little fun experiment. And yeah, so let's get into it. So starting off, this is all the stuff I used for the experiment. I used an oven mitt. Obviously I'm not trying to burn myself. Tinfoil to put the crayons in and heating and all that. Crayons, obviously. A knife to shave off the crayons. A toothpick to mix stuff. A pan as obviously to heat stuff up. And ice and bowls. That's all the stuff I used for this experiment. So starting off, me and my lovely girlfriend started shaving off crayon pieces and all that, and she actually took this class before, so she was able to help me out, give me some pointers, and yeah, she was really helpful and very awesome throughout this experiment. So while we were shaving, we accidentally put all the crayons together, all the different colors in a one bowl. I was like, oh shoot, the video said we were supposed to do that, like put everything separate, so we had to literally pick through every piece and separate them. That took a minute, but we were able to get onto the experiment. So yeah, first right off, I started making my sedimentary rock. Put all the crayons in the tin foil, grabbed a cast iron pan, and just started pushing it down. And when I was doing this, I realized I'm on carpet. It's like really soft underneath there. That's not gonna do the job. So I took it out, put it on my counter, and started pushing it down for a little bit, and it ended up working. It ended up doing a decent job. Should have held it down for a little longer, but yeah. So like I said, this is a sedimentary rock. So sedimentary rocks are formed through like the accumulation and compression of sediments such as sand, silt, and clay, and yeah, like all different sorts of like different sediments just come together and just through compression are formed, just like what I did in this experiment. Compression, just forming them together. So yeah, onto the actual sediment rock. This is what it looks like. It's kind of all clumpy a little bit. It didn't form that great. I should have held down for longer, but it's still, I got it. So that's good. That's what it looks like. Now on to my metamorphic rock. So I put all the crayons back into the tinfoil, threw it on my pan, got the heater going, and this is how it came out when I let it cool. It looks pretty. Looks kind of smooth. You can kind of see the little bits and pieces of the different colors of crayons, and much like a metamorphic rock, this was graded through high heat, and yeah. Now on to my igneous rock. I threw everything back in the tinfoil, threw it back on the pan, got it heating, took my toothpick, mixed it together right here, and took it off, threw it into my ice water, and this is what it made. Looks kind of rough, looks weird. Doesn't really look like a rock, but it formed. It did. It made something, I guess. Now, igneous rocks are formed through the solidification of molten magma or lava, and once they cool, they form into a rock. Now let's look at the comparisons. This is my sedimentary rock, and you kind of see, there's little bits and pieces of other sediments, like other colors of crayons, and you see that in these sedimentary rocks as well. There's little bits and sedimentary pieces all in there. Now on to my metamorphic rock. It looks kind of smooth. Some of these look kind of smooth. These ones look kind of smooth. These ones look a little rough. But you can see little bits and pieces of the other colors like I mentioned earlier. You can see that in these rocks as well. Now on to my igneous. I have a really hard time finding similarities here. I guess you could say it looks a little rough around the edges. Maybe I didn't do a very good enough job actually making the igneous rock. Maybe I should have been more careful or let it maybe, I don't know. Maybe I made a mistake here. But I guess you could say the edges are rough right here. Very rough around the edges. So yeah. Now, what are my interpretation of the results? Well, this experiment does a great job of showing how the rock cycle works. In the rock cycle, the same minerals and rocks can go through all the stages of the rock cycle, much like the crayons. It went through all the stages of the rock cycle. One thing I did not do a good job of is forming the sedimentary rock. I started off on the carpet, and I didn't really hold it down for long enough. Probably should have held on longer. And another thing, like I mentioned earlier, maybe I did a bad job forming the igneous rock because it doesn't look right at all. Now for the experiment questions. Why does this experiment not show metamorphism very well? Well, in this experiment, It does not do a good job showing metamorphism because in metamorphism, the rocks are formed through pressure. We did not use pressure of any sort. We just let it heat up and we set it off to the side and it cooled down. Now, what rock type really was generated? It was an igneous rock. So igneous rocks are formed just from heating and cooling. That's basically what we did in the metamorphism stage. We basically made igneous rock, but yeah, we just called it a metamorphic rock. What actually happens to minerals during metamorphism in the rock cycle? Under pressure, crystals and rocks may rotate, break into smaller pieces, or grow larger through recrystallization. This process involves minerals dissolving under high pressure and reforming in lower pressure areas. It doesn't break the rock, but changes its shape. These changes offer insights into the formation and movement of underground faults. I got this information from one of our sources in our lectures. So yeah, that's the experiment. It was a lot of fun, very simple, and I'm very excited to see your guys' videos, your guys' examples, and it was a lot of fun. So very excited to see your guys' videos.